All right. So today, the last section in this chapter. Okay. You need a calculator for today. So if you don't have one, please go back and get one. All right. We are going to look at what are called geometric sequences. We've done sequencing once before. We did arithmetic sequences. I would love to imagine that you remember what an arithmetic sequence is, but probably not. Okay. So an arithmetic sequence is when you add or subtract the same amount every time, or otherwise known as a linear function. Okay. Arithmetic sequences are the same as linear functions. Add the same amount, subtract the same amount each time. So today we're looking at geometric sequences, and we're going to find out, thank you, and we're going to find out that those geometric sequences in fact are the same as exponential functions. Now we've talked enough about exponentials to know that they do what each time from number to number? They multiply, right? And in fact, some may look like they divide as well, but truly they just are a form of multiplication. Okay, so either a value greater than 1 or a value that's less than 1. Okay, so that's what we're going to get into today. Your homework for tonight is already assigned to you in classroom. Essentially, it's like a digital kind of worksheet, so to speak. Okay, so it's not a form tonight. But can I identify a sequence? Can I find different terms? And then ultimately, can I extend it to what we call the nth term? Meaning, can I find some spot down the line? Okay. So our goals, can we identify and generate? So that's going to kind of take place. This last one, we kind of already just discussed, or I discussed, I guess maybe. A geometric sequence and an exponential function are essentially one in the same. So take a second, use your calculator, see if you can't tell me what those next two values would be. Hopefully, we don't have anybody come up with an answer that's greater than 32. Because if we do, that's going to be trouble, especially if you're bungee jumping. My x values are increasing by 1 every time. That's always going to be true. They're going to follow an addition pattern. Gracie, do you have an answer for this fourth bounce? 12.8. Somebody that got that have the next one, Aiden? Okay. Can somebody tell me what's happening from each of these down the line? Andrew? Okay, I 100% agree. You are dividing by 2.5 in each one of these situations. However, if we are going to define these bounces as a geometric function or a geometric ratio or sequence, we're not going to use division. So is there a way that you can figure out how to still produce those same results through some form of multiplication? Let's do this. Andrea, tell me how you got division by 2.5 in the first place. Okay. 200 divided by 80, 80 divided by 32. Each one of them gave you dividing by 2.5. Okay. All right. Okay, what's up? Ooh, what if you work the other way? Okay. What happens if you go the other way? Okay. Okay. All right. Here would be the only issue there, okay? If I did not know these two numbers down here on the end, and I again, I agree with you, 32 times 2.5 would give you 80. 80 times 2.5 would give you 200. It wouldn't give me answers down here. Bella? I did 32 times 0.4 and got 12. Okay. Why did you decide to multiply by 0.4 though? Because I did half and then it was too high, so then I went down one and it was perfect. Okay. All right. So first of all, understanding that these values were getting smaller each time meant that I was going to have to multiply by a decimal or a fraction that was less than 1. That was going to make them smaller. So you kind of guessed, but in educated way, like it wasn't just randomly guessing all over the place. Okay. What do you got? Ah. Yeah, the reciprocal of that. Okay. Okay. All right. So that's an option. Jack says, well, if you go this way, and that's dividing by 2.5, or really that could be thought of as 5 over 2, then the reciprocal of that would be to multiply by 2 over 5. Andrea, you originally told me that you did 200 divided by 80, correct? Go the other way. Do 80 divided by 200. Ah. Uh-huh. Yeah. Or 32 over 80. Or 12.8 over 32. Any one of those will produce the same result of 2/5, right? Oh, you're correct. 2/5 is the same as 0.4. They're equivalent to each other. Okay. So we can kind of, if we need to, we can work backwards, especially when these numbers are getting smaller and we know that it's going to be division, then we can kind of work in the reverse to help us through that. Okay. So the first thing we're going to do is just take a look at 4. I want you to tell me, is that a geometric sequence? If it is, what is this common ratio that's happening every time? Quinn? And what is that common ratio? Per- Good. So if I'm multiplying by 4 every time, then you could extend that pattern if needed, yes? So part of your homework tonight is going to look very similar to this, and then you'll see like 3 blanks, and I just simply ask you, if you know what the ratio is, then you should be able to tell me what the next values are, right? So in this particular case, the first one is 256, okay? The next one after that would be 1024, 4096, okay, 4096, all right. All right, what about this one? Maybe a little bit harder, shouldn't be too much harder. Is that a geometric sequence? From 5 to -10, from -10 to 20, and from 20 to -40. Logan, what are you thinking? Say that again. Multiply by -2 each time. Okay. All right. So then we would have what? +80, -160, and then a +320. Okay. All right. 2 more. Absolutely. Right. If my first number was positive, but when I go with the -2, that gets me the negative, but then the 2 negatives give me the positive, so on and so forth. All right. What about this one? Now, these numbers are getting smaller. So, either a decimal or a fraction that is less than 1. I think in this case, you're probably better served to think of it as a fraction because the decimal repeats. Any takers? Anna? Times -1/3. Very good. Okay. You may look at this originally and say that we're dividing by 3, right? So if we're dividing by 3, or excuse me, -3, then the multiplication would be by the reciprocal. So the reciprocal of -3 would be -1/3. Okay. So in this case, anybody tell me what the next one would be after that? -1/9 times -1/3. 1 over 27. Good. Remember, you're just multiplying those denominators together. So this would be 1 over 27. Good. That would be negative 1 over 81. Good. So realize how fractions are put together, right? Multiply numerators, multiply denominators. You're essentially just doing, sorry. No, I have somebody working at my house today, and so I just left my phone on in case, I guess I'm too old to be able to like hear the vibrate or something. I don't know, or feel the vibe. I don't know. Well, you do kind of, you can hear it, right? I mean, it sounds dumb, but that's a real thing, right? You can hear. What's that? All right, cool. See, thanks. Thanks for getting my back there. I think you were trying to help me. Maybe you weren't. I don't know. All right, last one. Is that a geometric sequence? Do you have it in decimal form right now?
No, I know how to do it. I know how to get the decimal, but I don't know how to make it a fraction.
Whoa.
Ignore that.
All right. Tyler, what do you got? What about 3/4? Multiply by 3/4. Okay. All right. These numbers are getting smaller each time. So that's either division or it's multiplication by a fraction or decimal that's less than 1. Take 384 and divide it by 512. Take 288 and divide it by 384. You should get that same 0.75 or 3/4 each time, which means that my common ratio is exactly what you said, multiplication by 3/4. Okay. What's that? 1/3? What did you do? What? Divided what? Okay, then you didn't get 1/3. You got 1 and 1/3. Or quote 4/3. Correct. Correct. If you go that route, you're going to get that you essentially have divided by 1.3 repeated, which really is 1 and 1/3, or it could be thought of as 4/3. And if you take the reciprocal of 4/3, that's where you're going to get that 3/4. Okay. Now you did say that you weren't sure how to undo that in your calculator. So if you have a graphing calculator right now, go ahead and do this. 512 divided by 384. You're going to get a decimal on your screen. Yes? Hit the math button on the left-hand side of your screen or your calculator, and the very first option says frac. Hit enter and hit enter one more time, and you should get that in fraction form.
Oh, yes.
Yes? That's what it says, FRAC. It just says frac. Okay? So there is no ABC button on a graphing calculator. However, you can use that to kind of get around that issue. Okay? All right, last thing we're going to touch on today. We have done this already about the idea of a subscript. This part right here, when we look at something like that, that subscript, it denotes location. So when we say a sub 4, we're talking about the fourth number in the sequence. Okay? If we said a sub 5, the fifth number, a sub 8, the eighth number. Okay, we did it with ordered pairs, y2 minus y1, x2 minus x1. Again, the second ordered pair, the first ordered pair. Okay, so let's take a look at this example here. In blue, is that a geometric sequence? How do you know that, Jack? Okay, so tell me this. If I said 3, 6, 12, 24, what am I asking you at this point? Anna? Say that again. Find the 10th number in the sequence. So take a second with your calculator. Tell me, what do you believe is the 10th number in this sequence? You already have an answer, or you have a question? 7, 7. Oh, before? Oh, that's a great question. I don't know.
Do it like that or no?
You're thinking in the right direction, but not quite what you have in front of you. But you're thinking that right way. Yeah. Arithmetic sequences?
Yeah.
Sure is.
Probably.
No. I like the thought though.
Oh, wait.
Yes. What do you got? That's it. I'm gonna go with no. Okay. You're missing one thing. You're missing one thing. I love the fact though that what I'm seeing on a lot of screens right now is people trying to use the idea of an exponent. Do remember that geometric sequences are in fact exponential functions. Therefore, the exponential form a times b to the x can be played into helping me find this answer. Okay. Now, I'm sure there's a lot of you in here that also just said, all right, times 2 times 2 times 2. Okay. Right? And we ended up with an answer, hopefully, of 1,536.
How come I got
Okay.
2,457? Oh wait, no.
Okay.
24,000.
Okay. Now, we're looking for the 10th term. You got an idea here of how I could do this without the times 2's? Oh. 3 times 2 to the power of 9. Does that give you 1,536? Sure. What is the 3 being represented as? The start. What is the 2 being represented as? Good. What I'm multiplying by every time. Why 9? Why not 10? I asked you for 10. Very good. Okay. So, had I said to you, can you find me the 17th term? What changes in this problem? Okay. Changes to what? A 16. So, it would still be 3 times 2 to the 16th power. And I have no idea what that is. So, anybody with a calculator? Hold on, because you're saying two different things and I did not acknowledge you. So, please don't just scream out. What's that? 196,608. Okay, so we did it with arithmetic sequences. It's a little bit different because there was no raising of a power in an arithmetic sequence, because remember, arithmetic sequences add and subtract. These multiply and divide, but the thought process is very similar. So that's the last thing we're going to do here is, what if I don't want a specific spot, but I'm looking for any spot? This number's not always going to be a 3. Correct. Why? Because what? Good. It can start with any number. So what am I going to write that would signify that I'm looking for the first number in the sequence? Not just 1, because 1 would make it look like the number's a 1. A1. Very good. Now, it's not always going to be a 2. It was a 2 in this problem because we multiplied by 2 every time. The number that we multiply by is called the common ratio. Okay. Unfortunately, in algebra, we just give letters to everything. So yes, this one's an R. Okay. And the power, when I wanted 10, I put 9. When I wanted 17, I put 16. If I don't know and I put n to just signify any number, then I'll put n minus 1. That's all right. We'll use it right now. Okay. So let's do this. I'm going to take this and I'm going to bring it over here. So let's use it for this one here. So we'll do it with this one up here. Let's say we want to find the, I don't know, let's say we're going to find the 8th number. If I want to find the 8th number in this sequence, the first thing I must know is what's the first one? Quinn? In this one here, it's a 1. So the first number is a 1. Secondly, I must know what R is. R stands for that ratio. What am I doing every single time? I am multiplying by 4. So this number is a 4. The last thing I must do is figure out what power I'm going to raise this to. Okay? It would be a 7. If I'm asking you for the 8th, that means I want 1 less because I've already got the first one listed. So whatever 4 to the 7th power times 1 is, I'll take your word for this answer. How much? Oh, I don't believe that. You did 4 times 7. I almost was ready to believe you. Ben? 16,384. How? Okay. Now, this also works with something like this one down here because we figured out what this common ratio would be with multiplication. Okay, so if I said to you, I'm looking for the 12th term in this sequence, you must be able to tell me, where did it start? What is my A1? It is 512, so that goes in my first set of parentheses. In my second set of parentheses goes what? Goes 3/4, because remember, this formula, A sub n, is found by taking the first term multiplied by the common ratio raised to the 1 less power than whatever you're looking for. So I would put 3/4 in here and I would raise it to what power? Caitlin? To the 11th power. Because you're multiplying. What's that?
12 minus 1.
Okay. Now, if I'm going to put this in my calculator, what do I do first? I raise the power. So probably a set of parentheses because you're going to put in a fraction. So parenthesis 3 divided by 4, close the parenthesis, and then raise it to the 11th power. Okay. So whatever that number is, okay, don't take it out of your calculator. And I'm going to do what with that number? Multiply it by 512. 21.62. Is it like end right there? 21.62?
No, it goes on. It goes 62 for 22.
Oh, okay. Okay. Okay.
How is it when you can't just type all of it in? Because you get the exact same answer.
As long as you have all your parentheses in there. Right. Because you typed exactly what I wrote. We don't always put all those parentheses to go around our work. do you agree with that or not? Yeah.
Wait, can you go back?
Any time that I substitute a value in, I always put it in a set of parentheses. Okay. And yes, if you typed in exactly what you saw, you would be in good shape. But if you did not, you wouldn't be. Because if you type this into your calculator, 3 divided by 4 raised to the 11th power, your calculator would say, well, there's division and there's a power. Which one should I do first? Your calculator is going to say, do which one first? The exponent. So it's going to do 4 to the 11th, and then it's going to do 3 divided by whatever that was. Because it doesn't realize, oh, hey, those two things belong together. It doesn't know that. So I put parentheses into everything that I know needs to be stuck together. All right. Your homework tonight, and we're going to start it together so we know what's going on, okay, is inside a classroom. So would you please go ahead and open your classroom, and then you'll need to sign in with your Google account.